1.16 intermediate value theorem. The first thing I want you guys to do is pause this video and copy down everything you see on the screen here. All right, ready to explain this now. So, just imagine this. Let's say you ignore all this right now. It's very fancy math language, but it's pretty straightforward. Let's say you're on an elevator, right? You start on the 10th floor. And then once you get off the elevator, let's say you close your eyes, you don't know where you went. You ended up on the 5th floor. You started at the 10th floor, you ended at the 5th floor. You're guaranteed to have passed the 9th floor, the 8th floor, the 7th floor, the 6th floor. If you start on the 10th floor and on the 5th floor, even though you never physically saw, you went through these floors. And that's what the intermediate value theorem is saying. If you have a value of 10 and the function's continuous, keyword, this function has to be continuous, no jumps or anything. You start with a value of 10. Let's say this value right here was 10, hypothetically. And this value here was a 5. You're guaranteed any value in between 5 and 10. So again, this is just guaranteed because there's a chance, right? If you start on the 10th floor, you could have, went up to the 11th floor, 12th floor, then back down to the 5th floor. But you don't know for sure. It's not guaranteed. What is guaranteed is any values in between. So the way we justify this is according to the IVT, there is a value C, so some X value input such that f of C is equal to whatever they want it to be, and C is in between A and B. So we'll do some practice and it'll make some more sense. Below is a table of values of a continuous function f. On the interval 0, x between 0 and 9, what's the minimum number of zeros? So between x, so from here to here, the x values, what's the minimum number of zeros? So again, we want to look at the outputs, not the inputs. So from 1 to -5, right here, it's continuous, so you had to cross a 0 here. It's guaranteed. From -5 to 3, oh, you had to cross a 0 again. From 3 to 7, you're not guaranteed to have crossed a 0. You could have, but you're not guaranteed. From 7 to -1, you cross a 0. So you see there's 3 zeros in this graph that have to occur. On the interval 4, x values between 4 and 9, what is the fewest possible times f of x is equal to 1? So from 4 to 9, careful, from 4 to 9. You first go from 3 to 7, you do not cross 1. But from 7 to -1, you cross a 1. So you're guaranteed one value right there. On the interval 0 to 4, careful, 0 to 4, must there be a value for x for which f of x is equal to 2? Explain. Well, from 0 to 4, right, we can take a look at this. F of 0 is equal to 1. F of 4 is equal to 3. Right, f of 0 is 1, f of 4 is 3. So we can follow this language on the top. 2 is in between 1 and 3. So according to the IVT, there is a value C such that f of C is equal to 2 and C is in between 0 and 4. Again, there's some input between 0 and 4 for which the output is 2. Question 4. On the interval 4 to 8, careful, 4 to 8 now, be very careful with these. Could there be a value of x for which f of x is equal to -2? So let's see what f of 4 is equal to. F of 4 is equal to 3, right here, and f of 8 is equal to 7. Um, could there be a value of x for which f of x is equal to negative 2? There could be. There could be, but it's not guaranteed. Again, in order to be guaranteed by the intermediate value theorem, the value you want has to be in between. So negative 2 is not in between 3 and 7, so no guarantee. Last question here. Will the function f of x equals x squared minus x plus 1 ever equal 8 on the interval negative 1 to 5? Explain. So this is like a really good like sample AP exam question you might see. Because this function's a continuous, well, it's a polynomial, so it's continuous. So I can just write f of x is continuous because that is a condition for using the intermediate value theorem. So we're going to find f of negative 1. That's parentheses negative 1 squared minus parentheses negative 1 plus 1, which is 5. Sorry, 3. My bad. Because negative 1 squared is 1 plus 1 plus 1 is 3. And then f of 5 is equal to 5 squared minus 5 plus 1, which is equal to 21. So you see 8 is in between 3 and 21, and this function is continuous. So according to the IVT, there is a value c such that f of c is equal to 8, and c is in between negative 1 and 5. Any questions, please ask your teacher, but otherwise continue the practice. Thank you.